So let's see. Whoops. I didn't quite get there. Okay, but yeah, you see it, and we knock it back, and kind of lands over there. Okay, so the first thing we're going to want to do here to add physics to our game and to allow this object here, the cart, to be able to be affected by things like gravity or other forces acting upon them is to add a rigid body 2D component to our projectile. So in the inspector over here, I'm going to go ahead and add in a rigid body 2D, and it'll be set to dynamic mode. Dynamic mode means that regular forces will be able to act on it. So if we, in another script, do something like add force of 1,000 to this, it'll be able to apply that force and be affected by things like linear drag, angular drag, and as long as gravity scale is not set to 0, gravity will also still be an impactful force on that object as well. So a dynamic rigid body makes it pretty easy for our game to get physics that are kind of similar to something like you'd see in Angry Birds. So it's generally the way to go for complex 2D physics. Now, in order to make this object launch, we're going to need a script to do that. It could either be on the object itself, but generally we would have other objects apply the force to the cart. But if you were to think about it logically, usually an inanimate object doesn't make itself move. It's an outside force that has to act on it. So just to simplify things, we could go over here and create a new empty game object and make sure it's not nested. And we could just call this God Powers, where anything we want to be able to do seemingly from nowhere as the god of this world, we could do that through this God Powers script. So let's create that here, and I'm gonna create an add, and let's open it up for editing. Okay, so now that we have this God Powers script open, we can go ahead and give it some functionality. So what I want this God Powers script to be able to do is to apply a force to our target, causing it to move, and the target, of course, is going to be this cart projectile. So the first thing we're going to need to figure out is our target. Now, there would be many ways for selecting a target, but to make this video a little bit simpler, I'm going to, actually, we'll make this a rigid body 2D, and I'm going to call this target. So in order for it to be a valid target, it has to have a rigid body 2D because we're applying a force to a dynamic rigid body. And then we need a function to actually apply a force. So let's see here. Public void apply force, and we don't necessarily need to pass a parameter of a target because we already have that set in the script, so we can just reference the variable setup here. But what we might want is a float value of the force. So how much force do we want to apply to the target? And we might also want a vector 2 of direction. So we'll have a force and a direction to apply that. And now all we need to do is add the force to the target. So let's see here. It needs to be a vector 2 of a force. So that'll be the direction times the force. So all we really need here is direction times force here, which returns a new vector 2D at the correct values. And that's actually it, I think. So that's really, really simple there. But we actually need a triggering event for this apply force method to be called. So one easy way to do that on the update method would be to check if an input key is being held down. So if input.getKey down. So if this key's down, I want to start getting ready to apply force, but I don't want to apply it yet. Instead, I'd rather charge up the force for a set amount of time, basically until the input key is released. And then once the key is released, it's going to actually fire projectile or apply the force to the projectile. And we'll make this a private Boolean charging, which defaults to false up here. And so if charging equals true, then we want to get the time charged is going to be plus equals time dot delta time. So basically the time since the last frame. And this needs 2 equal signs because it's checking to see if it's true, not assigning it. And also the time charged should default to 0 every time it starts charging. Let's see here, another private float time charged. And another thing we can check for here, if the input key is not down, it might be up. So we can check if the key was released, get key up, decode.space. And let's see here. So if the key is up, then we want to release the charging. And we also want to apply the force. So let's see here. That's going to be time charged times force multiplier, which we haven't created yet. And then the direction, we'll figure that out in a minute here, but I guess we'll just make that another public variable, direction, for now. And then after we apply the force, we want to make time charged. And then after we apply the force, we can make time charged equal to 0. Probably redundant. I think we only need to apply it either here or here, but it doesn't really hurt anything. I guess I'll only have it there once, since it's unnecessary. So let's see, if charging equals true, time charged plus equals time. Okay, so now we just need these variables up here. So let's see, force multiplier. That's something we can allow the designer to set in the inspector. So let's create, or actually we can make it a float. So force multiplier and public vector2 direction. So we'll need to set those values in the inspector. But aside from that, as long as we set these 3 values whenever we have this God Power script created in our scene, it should probably work. So let's go back to the inspector and see what happens here. So we need to set a target. So we can select that for the cart since it has a rigid body. Also renaming the cart would probably be a good idea. Let's call it cart projectile. Let's go back to guard powers. The force multiplier, I honestly don't know how much force we need to apply to that cart to make it move in a reasonable fashion. So I'll just try that at 100. And for the direction, let's start off by having it be 1 in the X, which means it's going to be going over this direction. And let's go ahead and hit play and see if this works at all. Okay, so first off, the cart fell through the floor because I have not actually added in a tile map collider here to this ground. So let's fix that real quick. So on the grid, tile map, we just want a tile map collider 2D, which will stop objects like the cart from falling through. But that will only happen if there's actually a collider on this cart as well. So on the cart, I'm going to add in, let's say, a circle collider. And let's resize it a little bit here. So that shape seems more reasonable. And now let's go ahead and get back to our scene. Okay, I'm gonna hold down space and let go. You can see it rolls along the surface there, not too bad. Not exactly what we're looking for, having a curved projectile, but it definitely is moving. Also, it might be cool to have a little text indicator here about how long it's been held down. So I think we'll actually add in a text UI component. So let's add this over here and we'll add it to the top left of the canvas. Change the color to white. And we'll make the font Penny Bold, which is a free font you can get online. And time held down, or charging time. And that'll of course be default to 0, but really what we're going to need to do is control that with our God Power script. So here I'll add in a text component, charging text, and using Unity UI, using Unity engine.ui. If this is set, then on update we want to set the text. So So if charging text is actually set, then charging text.text is going to be equal to basically this value plus the time charged. But we might want to allow someone in the inspector to change this value. So I'm actually going to replace that with a public variable. So we'll do a string and we'll call charging text intro, I guess. And we'll set that default value to that charging time 0. Also, we should remove those extra characters. So the actual value here is going to be charging text intro plus time charged. And I think with this text, we can go ahead and anchor it in the top right hand corner and push it away from the side a few pixels. So I'm going to offset it 10 pixels away from the top left corner. And on the God Power script, we can reference that text. Now, we might want a better way of doing this. Obviously, if we're manually referencing every object in our screen, if we remove those objects, then we run into problems. But to keep things really, really simple here for testing purposes, this is okay for now. So I'm going to also rename this text charging text to make it more clear what it actually does. And let's hit play. And let's hold down. Okay, so we can see that the text is changing, but it doesn't actually update there. And the reason for that is our text is just simply too small. So let's stretch it out a bit more. So now we just want to put this cart at an elevated space and add an extra brick underneath here so that when we apply the force, we'll actually be able to see a little bit of a curve because gravity will be applying on this while the forward force is also applying on that, and that's where dynamic rigid bodies come good. And then we'll actually make it so that when we apply a force here, we'll get an actual curve, something like this, that will hopefully reach this caveman guy over here. And then later we'll be able to have him bounce it back to the starting place. So let's go ahead and add in a couple extra tiles here. I'm not going to worry too much about the art consistency at the moment. And then let's get the cart somewhere on top of there. And we'll hit play and test one more time. So the charging time still not really updating that well. But you can see how when we fling that cart off the cliff, there was a bit of a curve there. And that's all due to the gravity. So the problem here with the text is that the float is trying to show every decimal point, which is going way too far for the space we have in the canvas text. So what we can do here is actually cut off some of the decimal points. So how we can solve this problem of the float having too many decimal points is to do a toString method, and then we pass in a string of basically how many decimal points we want it to have. So we could do 0.00, and that's going to be a float with 2 decimal points. So let's see if that's still working over here in play mode. Okay, so we hold down the charge button, and it has 2 decimal points. So that's pretty much exactly what we're looking for. So now we want to actually have this cart launch in a arc so that it will kind of land over here on the caveman. So we want it to go up and then come down. And obviously the easiest way we can force it to come down is to have gravity in our world. So I'm going to change the direction to 1 and 1. So this means it's going to be going in this direction initially. We can actually make it a little bit more high than it will be far by reducing the x. So now this, instead of 1, 1, it's something more like 0.81. And if we had 0, 1, it would be straight up. So let's go ahead and try this out. So I'm going to charge it up a bit, and let's release at 4 seconds. Okay, pretty close. I think we need about 3.5 seconds in order to hit that player object over there. But in order for it to hit that in order for it to actually contact with this character over here, that character is also going to need its own rigid body 2D. We will leave it as dynamic over there, and let's create I'd say a capsule collider. That usually works pretty well for characters that are taller than they are wide. So let's adjust that a bit. And let's see if we can make that hit this character over here. So 3.5 seconds. And what I expect to happen is that they'll apply a force to each other. So this guy got knocked off the cliff, very much Angry Bird style. And the cart bounced backwards, which is pretty cool. So you can see how complex physics interactions are made really simple with Unity's rigid bodies. But now the final thing we want to be able to do is to have this character knock back the cart to its original starting place. And we might also not want this character to move so much. There's a few ways we could do that. We could have this rigid body actually be a kinematic rigid body where it would not be affected by forces. And then in script, we would have it apply a force back over here. We could leave it as dynamic, and we could massively increase the mass so that it'll become a character where basically it is very hard to move because it would need a large amount of force to move that mass. We could also increase the linear drag so that if there's any force applied to it, it fades out very, very quickly. So those are a few options there. Maybe I'll increase the mass by 10 and the linear drag by 0.1. I mean, it is on a surface here, so there would, I guess, be some drag or tension due to that. But now we're going to want kind of a reflection script to knock this projectile back over towards the starting point. So let's create a script, and I'm going to call it knockback. So create an add, and let's edit it. So the moment where it is in contact with the other object is going to be a onCollider enter 2D. And when that happens, we're going to want to get the rigid body 2D of the collision target. So rigid collider's rigid body, I guess. Probably can get a better name for that if you want. And let's do collision dot other rigid body. Oh, okay. I guess it already had a property for picking that up, so that's pretty easy. Actually, if that's the case, then we don't even need to get it because it's already got with this property over here. But we need to pass that into a function. So we're going to call this function knockback, and let's pass in the collision dot other rigid body here. And now we create that function. Oh, well, this has the same name as the script, so, but we're trying to give it the same name as the class, so that is going to cause us some issues there. So we could either change the class name or we can change this method we're trying to create. I guess we could call it commit knockback or something. And let's create that function. So it's going to take this other rigid body, and we want it to add a force to it. So the force is going to be a variable we have to set. So let's make it a little bit simple in this one, and we'll just make it well, let's actually make it consistent with the other one. Let's make it a direction and then a float force multiplier. We can make it a little bit more specific, knockback direction. And force multiplier, that's specific enough, I guess. So we want knockback direction times the force multiplier. And that is going to be set in the inspector. So the knockback direction, in this case, it's going to be something like a -1 and then -0.5. And the force multiplier, let's just try it at, oh, I don't know, 1,000. One other thing I want to add here for fun is going to be that when it does do that knockback, it changes color for a second. So it's like this guy's getting mad and he's knocking back the cart to where it came from. So I want him to turn red. So how we could do that is on awake, we get access to the sprite renderer. So sprite renderer sprite renderer equals get component sprite renderer, and let's create a private variable for that. So sprite renderer, and we could even make a color for it to change to, and we'll call this the enrage color. And we could say enrage duration as well. And we'll default that to 0.1 f, which is going to be 0.1 seconds. But we'll also have to see how long has it been enraged. So float time enraged equals 0. And I will have a public void enrage method, which will change the color. This enrage method will take the sprite renderer if it exists, and the color will be set to the enrage color. But we're also going to want to keep track of what the original color was. So let's do that here. So original color is equal to sprite renderer dot color, and let's set a variable enraging is equal to true. So the boolean enraging equals false, and then private color original color, well, we don't set that yet, we set that here. Okay, so that'll start enraging, and then we just need a function to stop the enrage. So stop enrage. Or actually, I have an even cooler idea for you guys here. So let's do this with a coroutine. So a coroutine is basically when some code runs asynchronously on a separate thread, and when it reaches a certain point in the code, it'll have a statement that'll look like yield return, which means until this requirement has been met, go do everything else inside of the Unity engine, everything that's happening inside of the game, and then cycle through everything and come back to this script and see if the condition has been met. I think Unity actually doesn't really have true multi-threading. It's more like you just delay the rest of this script from running, and then you go do everything else and you come back to it, rather than it truly running on a separate thread. But I'm not 100% on that. But anyway, I can show you how it works at a base level. So we need to make this function an IEnumerator, because it's going to be returning a coroutine. And we won't need this boolean for enraging equals false, and we won't need this one for time enraged as well. So it does save us having some extra variables there. So how we trigger this method is that when the knockback happens, we want to start a coroutine, and this is going to be the enrage method, and we call it just like that. So start coroutine with the method we want to run inside of that coroutine. Now this isn't a true coroutine yet, because there is no returning of a value. It has to either return null or yield return when we want it to pause and do other stuff. And where we want that to happen is going to be right here. So I'm going to do a yield return new wait for seconds. And this is where we're going to take that enrage duration. So enrage duration, which in this case is 0.1 seconds up here by default. So it's going to essentially wait for 0.1 seconds, and then it's going to come back into this script, and it's going to do something, which is going to be to return the original color. So sprite renderer.color is going to be our original color, and that's it. So this whole coroutine is going to be, if there's a sprite routine, a sprite renderer, it gets the original color, it assigns the new color, and then it waits for a specific amount of seconds, 0.1 seconds in this case, and it returns the original color to that sprite renderer. So really simple, but a cool way that we only need one method here. We don't need to create a start and stop. We can just have it all be inside of one method here. So yeah, these can be really useful for a lot of things when you get the hang of them. So let's see here. I think we just need to test it and see what happens when it bounces in there. Oh, we do need to set an enrage color, so I made that publicly accessible, so our inspector guy can go ahead and choose this enrage color for the red. Let's just make it a really deep red over here. Don't know exactly how that'll look, but it should be okay. And of course the alpha, we want that set to 255 so that it'll actually still be a visible character. So let's try to make this. Ooh, what happened there? Okay, I'm not certain, but I think that might have been due to the capsule collider shape there. I'm gonna try freezing the rotation here, so the character can only move left and right. It can't actually go rolling around like that. That doesn't make too much sense. Maybe it was the angular drag. I'm not 100% certain. But let's just play around with it a little bit and figure it out. Okay, so it looks like there's a force being applied to it. Let's actually take off the freeze rotation and just let this character fall down and then see what happens. Maybe it was because it was stuck. Okay, you know what? It's the knockback script itself. So the commit knockback, so in the knockback script, I think other rigid body is actually referring to this rigid body, not the one it's in contact with. And secondly, we don't want it to apply to ground colliders. So I guess we'll need to filter it out a little bit. So first off, let's do the collider.rigidbody. So let's get the collision collider attached rigid body and see what happens here. So right now, I believe this would be applying the force to the ground, but the ground obviously can't move because it's a tile. Object reference not set to... Yeah, okay, that makes sense. So let's check if there's even a rigid body on the collision collider. So rigid body 2D collider body is equal to collision.collider.attached body. So if collider body, then we will commit the knockback. Otherwise, we just kind of ignore it. So let's get that rigid body 2D class there. So now we're basically just filtering out that this knockback will only happen on anything that has a rigid body 2D. And I guess that's fine. You could go another step and make it so that like you only allow commit knockback to occur if they have like a specific tag, like if they're tagged with projectile or if they have a specific script on them. Basically, however you want to filter it out, you could do that here. But let's see if this is good enough for our purposes here. So I'm gonna save that script again and we'll go ahead and hit play. Okay, so nothing too weird's happening. Let's try getting the cart to actually hit that player. So 3.3, ooh, that was a nice knockback, but not quite in the direction we wanted, and he still went flying off the cliff. So maybe this guy needs a little more mass and linear drag. And let's also change that direction. So let's make it -1 and then -0.5. So let's charge it up here. And he hits it. Ah, okay. So this knockback direction, that's actually -y. So that's why he's punching it down to the ground. We want it to be up and to the left. So right now it's something like this, which is kind of what we're looking for. Let's try this one more time. Okay, so not bad, kind of close to what we were looking for. Maybe a little bit too much Y and a little bit too much force. So we'll try it again here. And yeah, that's pretty close to what we were looking for. Now, if you don't want this guy to move at all, you could just freeze all of the constraints. Now, if you don't want this guy to move at all, you could just change the body type to a static rigid body, which will still be able to interact with this cart over here, but this itself will not move. So let's try demonstrating that. So this time when we charge up and land on him, it should only move the cart. So you can see the enrage happens, but this does not move at all. So kind of up to you on how you like it. I'll leave it as dynamic because I think that looks a little more funny. Okay, now one more thing. Let's say that with these forces, you wanted to make sure that this cart will go back in the exact direction it came from, and you want to completely discount the forces that are acting on this cart when it gets here. So basically, you want to control exactly what force is going to be coming over here to this location. Well, we could do that pretty easily here. So I'm going to add in an optional piece of code you can run here, which is going to be to eliminate force. We're going to do that on the collider body. And actually, let's make that a public variable. Eliminate starting force, and that'll be a boolean. We'll set to true. So if we have that set, then we will actually run this method. Otherwise, we'll discount it. So you can choose whether or not you want that to be there. And let's make this function here. So eliminate force that takes a rigid body 2D. Actually, you know what? Making an entirely separate function for this is probably overkill. We could just go on the collider body 2D here. And I think on this collider body, what we want to do is set the velocity to, well, basically vector 2.0. So we want to take all of the force and eliminate it before we actually add in this knockback force. So that guarantees that the force acting on the object after this will be exactly whatever the knockback force is, and that there'll be no other outside forces. Now, of course, gravity will continue to affect it after it exits this function and a couple frames pass by. But at this point, we will know what to expect. I believe anyway. Let's see if that actually works. So I'm going to launch it at this guy here, and let's see if... Okay, so that was one version. Okay, so we just have to test this a few times and see if at all times the exact force goes back consistently. And so far it seems to be doing its job pretty well. And then we just kind of need to fine tweak the numbers. So let's see. Whoops, I didn't quite get there. Okay, but yeah, you see it kind of goes back in the same path because it has the same force applied to it. So now what we could do here is just lower the force down a bit, like to 400 or something. And we knock it back and kind of lands over there. So as far as using dynamic rigid bodies and applying forces go, that's how you can launch a projectile towards an area and then have something knock it back. Now, you might say make this guy into a baseball player, have him swing a baseball bat with an animation, and then only if that baseball bat is actually swinging will allow the knockback function to occur. But this should give you a really good idea of how you can get these kind of interactions going. Now, if you do need your projectiles to follow an exact path, then what I would recommend for you is to, instead of using dynamic rigid bodies, you use kinematic rigid bodies. And then you could define paths or target positions for an object to move to over time. But so kinematic rigid bodies don't use forces, but you would instead modify the position of the object directly, and you would do it on the rigid body, like rigid body position, set it to a new position.